Doing reverse code engineering starts off with understanding the meaning of every bit and byte. Simply weaving the bytes content requires developing tools that aid in the reading of files and objects. Parsing the adding meaning to every byte will require another tool. Reverse engineering has evolved with tools that are continuously updated when encountering new software technology. Here we have categorized these tools into binary analysis tools, disassemblers, decompilers, debuggers, and monitoring tools. Binary analysis tools. Binary analysis tools are used to parse binary files and extract information about the file. An analyst will be able to identify which applications are able to read or execute the binary. File types are generally identified for the magic header bytes. These magic header bytes are usually located at the beginning of a file. For example, a Microsoft executable file and exe file being with the MZ header. MZ is believed to be initials of Mark Zbychowski, a developer from Microsoft during those days. Microsoft Office Word documents, and on the other hand, have these first 4 bytes as their magic header. The hexadecimal bytes in the presenting screenshot reads as a doc file. Other information such as text string also gives the hints. The following screenshot shows information indicating that the program was most likely built using Windows Forms. Disassemblers. Disassemblers are used to weave the low-level code of a program. Reading low-level code requires knowledge of assembly language. Analysis done with the disassemblers gives information about the execution conditions and system interaction that a program will carry out when executed. However, the highlights when reading low-level code are when the program uses Application Program Interface (API) functions. The following screenshot shows a code snippet of a program module that uses the getJob API. This API is used to get information about the printer job as shown in this picture. Debuggers. Disassemblers can show the code tree, but the analyst can verify which branch the code flows to be using a debugger. A debugger does actual execution per line of code. The analyst can trace short codes such as loops, conditional statements, and API execution. Science debuggers are categorized under dynamic analysis and perform a stepwise execution of code. Debugging is done in an enclosed environment. Various file types have different disassemblers. In a .NET compiled executable, it is best to instead disassemble the P code and work out what each operator means. Monitoring tools. Monitoring tools are used to monitor system behaviors regarding file, registry, memory, and network. These tools usually tap or hook on APIs or system calls, then log information such as newly created processes, updated files, new registry entries, and incoming SMB packets are generated by reporting tools. Decompilers. Decompilers are similar to disassemblers. They are tools that attempt to restore the high-level source code of a program, unlike disassemblers that attempt to restore the low-level assembly language source of a code of a program. These tools work hand in hand with each other. The log generated from a monitoring tools can be used to trace the actual code from the disassembled program. The same applies when debugging, where the analyst can see the overview of the low-level code from the disassembly, while being able to predict where to place breakpoints based on the monitoring tool's logs.